In this video, we're going to look at hypothesis testing. First thing to do is to download and open the chapter 10 shell file. And when you do that, make sure that you enable content. If you don't do this, box plot cannot be prepared. Now the data, this is about a study of reading activities, so especially designed reading activities, whether that would be beneficial to improving reading skills. So randomly selected 21 third grade students were assigned to the specially designed program, and another 23 randomly selected third graders were assigned to the same curriculum but without the designed program. At the end of the 8-week period, the students were given a standard test called DRP test, and the DRP test scores for the students in the treatment group are given here, and the students in the control group who did not go through the special reading activities but the curriculum was exactly the same are given here. Now we want to test whether the special reading program was beneficial, which means whether the test scores for the treatment group is it better than the test scores for the control group. So first let us define what the populations are. Population 1 is DRP test scores for the third grade students who participated in the specially designed reading activities. That is our treatment group. Population 2 is the DRP scores of third grade students who did not participate in the design program, and that is our control group. So mu sub 1 is the average DRP test score for the treatment group, and mu sub 2 is the average DRP test score for the control group. And our objective is to see whether the special reading program is beneficial, so which means we want to test whether in the alternative hypothesis mu sub 1 is greater than mu sub 2. The average test score for treatment is greater than that of the control group. In other words, mu sub 1 minus mu sub 2 is greater than 0. So the null hypothesis then, mu sub 1 is less than or equal to mu sub 2, which means mu sub 1 minus mu sub 2 is less than or equal to 0. Now to do the test, this is the test statistic, but we don't have to use this test statistic because we're going to use the data analysis command. So go to data analysis, select, there are several tests at the bottom, and we want to test assuming nothing about the population variance. They are unequal. We don't know what the population variances are, and the variances can very well be unequal. So now the first variable range is treatment, second variable range is control, and since we included labor, now the hypothesized mean difference is 0, and we want to put the output starting from there. Click OK. Then we have the output. Let's format the output. Okay, I have a legend for the output right here. So the first row is mean. So we have x bar sub 1, x bar sub 2. Second row is variance, s sub 1 squared, s sub 2 squared. Observations is sample size, so n sub 1, n sub 2. That's d sub 0, the hypothesized mean difference comes from the hypothesis. Degrees of freedom is to be calculated using the complex formula that I talked about in the textbook. Data analysis gives you the output here, gives you the degrees of freedom right here. T statistic value, which is this formula, and then the p values are given by these probabilities. The first one is one-tailed test, the second one is two-tailed test. So what we have here is one-tailed test, and therefore our p value is that. Let's convert, let's format it to a percentage. Then the conclusion is, since p value is less than 5%, let's assume 5% level of significance, reject h sub 0. And now we want to interpret that, two-part interpretation. First part is about the decision, so we have sufficient sample evidence to conclude that the average DRP test score for the third graders who participated in the specially designed reading activities is greater than that for the third graders who did not participate in the activities. That's the interpretation for the decision, and then the p-value. The probability this conclusion is wrong is 1.32%. Now let's justify the text. There is one more thing we can do to bring out the actual decision, and that is to set up box plot for the two samples. So highlight the treatment values to control P. That's the first box plot for the treatment group. Then one for the control group. Now I'm going to format these two box plots, and I'll show you the final result. So here are the two box plots. You want to make sure that for the purpose of comparison, the y scale is exactly identical for the two box plots. Here the first one goes from 0 to 80, the second one goes from 0 to 90. So the first one should be changed to, so click on the scale, format axis, and change the maximum to 90. So now they are comparable. So visually you can see that the hypothesis is true. The average values are in general for the treatment group is larger than the control group. In addition to that, we also see that the values are much spread out in a wider range for the control group than for the treatment group, which in itself is probably a good thing.